that from 0 to 1. And then Aiden or Douglas, can you tell me how to evaluate this?
You plug in 1 into the equation and subtract it from it plugged in 0.
Yeah. So we're taking this, and then from that, we are subtracting the same thing, but with a 0 subbed in. Okay, so we have 3, 2 times, so 1 squared is 1, 2 times 1 is 2, and 2 plus 1 is 3. So I'll have 3 cubed, and then minus, this becomes 0, this is a 1, so 3 times 1 cubed. 3 cubed is 27, so I'm going to have 3 times 27 minus 3. And 3 times 27 is going to be, let's see, 3 times 7 is 21, so it's going to end in a 1, and then 81 minus 3. You guys agree? I could have done that wrong. Okay, and then when we subtract 3, we should get 78, which should be our final answer. You guys agree with that? Are we all good?
Yeah.
Okay, what questions does anybody have before we move on? Okay, if there are no questions, we're going to go ahead and start notes for today. Okay, so normally if we were in class, what I would have done is I would have done practice. So last class we went through Venn diagrams, right? And we went through all of those notes, okay? And so today we would have started our class with Venn diagrams practice. So I have this matching activity that I wanted everybody to do, okay? And I have 9 Venn diagrams here. Let me zoom out so you guys can see all the way. Okay, so I have 9 Venn diagrams of all these chords. I have some set notation here, a description, and then vocabulary, okay? There are 9 different set notations, 9 different descriptions, and then there's only 5 vocabulary pieces, so not every single Venn diagram will have a vocabulary piece. And I would have had you literally cut all these pieces out with scissors, and I would have had you glue them to the appropriate Venn diagram, okay? Because we're online and that's not really feasible, I am very proud of myself, and I, hold on one second, I'm very sorry, went to Desmos and I made an online version. So you guys will do this. So if I scroll all the way down to today, if I ever can make it there, what on earth? All these copy things are on there. I need to fix that. That's annoying. Okay, well, I'm sorry about that. But if you go to activity 1 for today, you should see that we're going to do notes during this synchronous meeting, but then during your asynchronous time, you're going to do this card sort. So you're going to click on this link, and it should take you to this Venn diagram notation matching activity. So you'll enter your name and click go. Okay, and make sure you actually put like your name so that I can give you credit for this. And it will take you to the activity. And because it was insane to try to do all of them on one page, I broke it up into sets of 3 Venn diagrams. So you'll have 3 Venn diagrams for each slide that you do. Oopsies. And so let me move this up. Oh my goodness, it joined those 2 cards. Okay, go over there. Move my Venn diagram. Split these up. Okay, so now I can move this guy there. Oh, now whatever. Okay, so now I'm gonna look at this Venn diagram. Hold on, I also think I heard somebody trying to get in. Okay, so you'll look at this Venn diagram. We can do this first part together. Okay, so we have pretty much everything but this like part of B shaded in. So what do you guys think would be the set notation for this? Anybody have any ideas? We move this so that we can maybe see it. Having all these things is too much. Okay, so we're looking at the set notations. So we have these three things here. Do you think it is this A intersect B, the union of A and not B, or A minus B? Anybody? So out of these three different set notations, what do you guys think it is?
Is it the union?
Yes, so it's this union one because we have all of A, right? We have all that shaded in, and we're adding it to not B, okay? Not B is all the stuff outside of B, all right? Then if we look at our descriptions, so we have three descriptions here. We have in A or not in B, in A but not B, and in both A and B. What do you guys think out of those three descriptions?
In A but not B.
So in A but not B. But what about this little intersection right here? Like that is B. So if it's in A but not B, wouldn't these elements contradict that? Anybody else?
Is it in A or not in B?
Yes, because we know that it can be an A, or there's also the or option, not in B. That is different from this because it is telling us that we can have either or of these things. This is saying that it's exclusive. We can have in A, but it definitely cannot be in B, okay? So this is like in A and not in B, but this one is an or, okay? And then we can check our vocabulary. It says the intersection of A and B. We only have one vocabulary section here. This definitely doesn't look like just the intersection, so I would leave those three cards alone. Okay, assume that those match up, and then I would work to figure out the set notation and description for each of these other ones, and one of them will have a vocabulary. So two of them will be sets of 3 cards. One of them will be a set of 4 cards. I believe on the next slide, all of them have 4 cards. And then on the slide after that, it's just like this one, 2 do and 2 do not. Or 2, I'm sorry, 2 do not have 4 cards and then 1 does. What questions do you guys have on this matching activity?
Will it be in this specific order of where we get this specific like set of things?
What do you mean?
Like, okay, like are the like different slides we get like, or is it like random the order, or is it just like?
Oh, I don't think it's random. So you'll like put all these together. So I'm just gonna pick a random description, a random set notation, and then I'm just gonna stick all these together. So you would stick them like that, and then let me see. And then you would click this next button up here, and it takes you to a new set. And you would organize those, click the next one more time, organize this set, and then you would, I think that, I mean, it's gonna probably force me to like put them all together before I can click next at the very end. But that's, I don't think it randomizes those 3 slides, like these 3 groups of cards. What other questions do you have? Okay, So you'll do that on your own. And then the last thing I have is some partner work. That's some Venn diagram partner practice. That should be an activity 2. We have it here. You guys can work with each other. You can work with as many people as you want. Yeah, in class, you would normally do this as partners. And then you have homework for today, and I believe the homework is on Venn diagrams. Okay, so now that I've basically used all of our time, we should go ahead and get started on our notes. So we're talking about combined events today, which is new, okay? So all the stuff you're doing second today, we normally would have done first, and then we would have done something new. But today we'll just start these notes and then we'll finish them up next period. Okay, so let me put all this practice stuff away and find my pen, and we can go ahead and get started on combined events. Any questions while I'm just reorganizing myself? Oh, wow, it's so bright. Maybe if I zoom in, it's a little better. Okay, so combined events. So the question we're asking here is, how can we find the union of 2 events? We're literally combining those events. So here it says, consider 2 events, A and B, where P of A is 7 out of 10, P of B is 5 out of 10, and the intersection is 4 out of 10. Fill out a Venn diagram below to represent this information. Okay, so I'm going to just draw a box around this Venn diagram. Okay, and that's going to represent my sample space. Then I'm going to have A and I'm going to have B. Okay, and I'm going to highlight what these guys are. So we have P of A. P of A is the probability that anything in this entire circle happens. Okay. P of B is the probability of anything over here happening. Okay. So this is going to be the sum of everything that's in here and there. And this will be the sum of everything in here and there. So it's wise to start off with the intersection, because we know that the intersection has to be 4 out of 10. Okay. Now we have to add something to 4 out of 10 to make this whole pink circle 7 out of 10. So 4 plus 3 is going to give me that 7. So I put my 3 out of 10 there, giving us a total for 7 out of 10 for this whole probability. Then 5 has to be my total probability for the blue section, the B section. 1 plus 4 is 5. So I'm going to do 1 out of 10 for this. I'm sticking my probabilities in there, not like the number of elements necessarily. If it were the number of elements, I would have done, well, it looks like there's 10 total elements. So you would have 3, 4, 1, that's 8, and you would have 2 outside of here. Okay. So now the probability, well, first, are there questions on any of that before I move on? Okay, there are no questions. We're looking to find the union of these guys, the probability of A union B, okay? So what's the probability of all these guys happening, of anything in these circles happening?
Four-fifths.
Yes, or 8/10. So at 8/10, just because we're adding the numerators, this does reduce to 4/5. Thank you. Okay, and if we looked at a Venn diagram and shaded it in, it would look like all of this stuff being shaded. Okay, now it is tempting to say that the probability of the union of A and B, which is all of this stuff, is equal to the probability of A plus the probability of B.